While since I've put out any sort of video whatsoever talking about specific technologies, and then there's very specific reasons for that. And then to me, it's there's a lot of hype around like anything that comes out, right? And there's a lot of AI hype in general, and then there's a lot of product AI products that have come out and that come out like on a weekly basis, really. So to me, I don't want to contribute to like the hype train and just be, oh, here's hyping up the latest release of whatever has come out. So if I'm releasing a video like this on a particular like piece of technology, in this instance NanoLlava, to me it's that there's a very specific reason why this particular technology is actually like something that you should check out, and I'm actually going to show you how to check it out as well in my video. The why you should, what it does, and how it works. That's kind of what my general approach is going to be for this overall. And then so let's talk about NanoLlava in particular. NanoLlava to me is a big revolution in this area, and not because of its performance, but if you're looking in this arena, and then if you're paying attention on the back end to costs with regards towards all of this, NanoLlava significantly decreases the costs involved with image to text on the back end by about 14x. And then so to me, that's like significant major breakthrough, right? So technologically, it's cool. And then economically, like it's on a back end, that's honestly what is my biggest draw to this model, because so NanoLava's competition and what it's based off of is essentially like the first like Llava models. So you have Llava 1.5, and then the latest version of Llava is Llava v1.6, and then the like kind of highest end Llava v1.6 model is Llava v1.6 Mistral 7b, and then so it's a Llava model kind of doing the same thing that we're looking at over here, but with a 7B model, whereas the NanoLlava that we're looking at there, it's combined. So it's using Kien, which is like a 500 million parameter model, and then it's also utilizing like Google, and we'll talk about the OCR technology, like the image recognition, optical character recognition technology that it's using, but that adds on like another 800 million parameters. So it clocks in total about like 1.3 million parameters, and then Mistral isn't exactly 7 billion, it's rounded down. So in average, like in total, it's about 7 times less than overall to run than Mistral 7B, which is important, right? Like it's again, like if you're talking about cost per tokens, if you're talking about your like load on your GPU, everything that would be possible on the back end, shrinking this down by 7x is big, right? And then so I don't like all throughout technology, like Moore's law, right? It's been like shrinking of technology and things like that. And I think people don't pay attention to that as much in the LLM game and like in AI overall, but like that same like shrinking and that is involved with all technology and all technological aspects, you see that 1,000,000% going on within this, right? We just shrunk 7x, so like pretty cool, right? Pretty cool overall. And then it's the question is, then does this model work? And then we can just do the simple test here. This is the like who's this guy? This guy Spider-Man from the Marvel Comics universe. And then so that gives you kind of just a general idea of what it does, right? Like so overall, this is really simplistic. And then so let's next break down kind of the cost of these things, right? And then like the why exactly I think that this is so revolutionary from a cost perspective overall. So if we're talking about like let's say that you want to go with the highest end, right? Like which is like let's say GPT-4 Vision, and then you utilize GPT-4 Vision to like generate and like look at an image and to like interact with an image, like exactly what we're doing here. You're gonna be paying on average about like 6 cents per image input and output, right? If we had done this within like GPT-4 Vision, it'd be about 6 cents. If we'd done this with this with the Llava 7B model, it'd be about 2 cents. So 3x cost savings, pretty big, right? And then so doing this with the NanoLlava model, all of a sudden we're at like a fraction of a penny, and we're at like a good fraction of a penny, right? Like a quarter of a fraction or less, a quarter of a penny or less, which is like amazing. So from a cost perspective, this is gold, right? And so I'm talking about this like overall from a like a cost perspective. Is this going to be better than GPT-4 Vision? No. Is it going to be better than Mistral 7B like Llava? No. But it's going to be a fraction of a penny compared to 2 cents, and like and a per image. And then like at the end of the day, I really care about those things. And then so uh, if you're watching this video and you made it this far, you probably care about those things too. And then so that's what sells you on this model. And then so the question becomes then, how do we use this, right? So okay, I've sold you on it. Like let's talk about it. Like what would you actually do from here to actually use this model? And then so from Hugging Face, it's pretty straightforward, right? So we know the model name, and we know the model name here is NanoLlava. So then in this instance, from Hugging Face, I'm just going to go here to the main page. I'm going to go to models. I'm just going to search for the model, NanoLlava. And then here, cool, I've got my cool model card. And then like to me, I like to look at the model card. Like at first I would just skip the model card. So you can just go right here, just using transformers, and then get code that you want from here, right? But I'm going to show you something especially, and it's a special trick that is especially apparent with this particular model as to why you don't just jump straight over here. Let's take a look through the model card, look at the description, cool, and then we've got some benchmark tests, cool, usage, and then we've got our code, cool, right? So then like this is the most important part. But then what we can see here is this is the code, so the usage in transformers, this is what we would get this second cell here if we clicked on this usage in transformers, which is what we want. But then we also want this pip install U transformers accelerate flash attention. And then so we're going to copy this. This is a package that I don't normally install on these things. So if we're going through and then we're just grabbing from transformers, I wouldn't grab that package, right? Like there's no way or no reason for me to install this particular package. And then so the only way that I know to install this package is by just taking the extra step of, rather than just grabbing it here, just going down and looking at it and saying, oh, okay, there, like, let's make sure that we've got that in front, right? And then so we just do this and this. And then so I'm just straight up just copying this code here from here. And then if you don't know what I'm copying it into, it's called Google Colab Notebook. Google Colab, very straightforward, it's free in this instance. And then in a lot of instances, and then it just essentially allows you to run like Python code and run like neural networks and LLM models and what we're doing here in like a Jupyter notebook. And then so that's what we're doing here. And then one thing I am going to do is I'm going to go here real quick to runtime, and I'm going to change this runtime type to a T4 GPU. I think I don't have to 100% technically in this instance based off of what we're running, but I do like with experience with this Kin, like even though this Kin's like a small model, right, like 500 million parameters, it's still like if you're not connecting it to GPU, it's like slow and it takes a lot of resources. So I'm just going to connect it there, and I'm going to hit play on both these cells. Just hit play on both of them here. It's going to take them a while to run because it's going to install this package here, this transformers accelerate flash attention. I've pipped it, like I do a lot of pip installs of the accelerate package, and then so like this accelerate flash attention, I'm assuming it's a fork of the accelerate package, and accelerate is you use it a lot for LLM models that are utilizing Hugging Face transformers, and then it specifically applies with NVIDIA graphics cards, which we're running here with the T4. And then it's just like a package that like allows the models to like run faster and more efficiently. You can see here it unpacks and unloads lots of NVIDIA CUDA, and then that NVIDIA CUDA on the back end. Like so, I like to say that AI is like it has a bias towards NVIDIA, and then it does, right? Like it's like and biased. It's biased towards NVIDIA because of CUDA. Like on the back end, and then so like a lot of packages, and then so it's when you ask like, well, like why does AI generally like rely on NVIDIA cards as opposed to like AMD? Like why isn't AMD making out like bandits like NVIDIA is right now? And it's because of CUDA and the CUDA packages. It's like a bias built into AI. Like it's the best way to frame it, right? And this is a big package, cool. So then it's finally done, I think. and then it's going to move on to actually loading our model. And then I would expect that our loading of our model would take this long. Cool, 1 minute. Yep. So it took a while to install, and then so I don't have to grant it access in this instance, but I do because I will grant it access in this instance. Just I have my Hugging Face token saved in there, and then so it's just easy for me just to grant it access, and then it doesn't show it, and then cool, there it is. And if I share this, I'll probably disable that. But then so now it's just running the model, and then so just going through the code here, it's pretty straightforward. So we're importing a few packages from in addition to that accelerate package, and then we're also getting an error, which is no such package. Oh, okay. Interesting. So that's why you should read this code first. So we have to load an image here. Do we have it? I think I have a sample image. I don't. So let's upload a sample image here. I think I definitely have some sample images in my downloads. Copy path. There we go. And now let's rerun this cell, and then it should be good, right? And then so that's one thing to highlight is, so like this is a Llava model, right? So you need to, it will error out if you're not loading an image into it, as we just saw. And then so because it needs an image, and then I should probably walk through a few things that I did here with the Colab notebook, right? Because to me this is second nature. But so I saw the error. I read through the error, and then I saw once I saw the error and I read through the error, I just went through and I saw the line that it was erroring on, which is this image here. And then once I saw that this line here, I saw that it had it was a generic filler name for that particular file path, and I would have noticed that if I'd actually read through all the code before I executed it, which I didn't, so that was my fault. And then so doing that, I saw that I actually had to rename that path. And then so knowing Colab over here on the left-hand side, you've got a few tools here, right? So the very first thing is when you saw I loaded this notebook, you saw that grant token access, that's here, right? If I click on this key, that's where that token would come from, and that's where it's coming from. And then this is for functions. This is for searching. I think this is for table of contents. There you go. And then this is the one that you're going to use the most, which is files, right? And then so I went immediately here, and then so you'll see in your files you've got sample data, and then so when you load and work with Colab, you've got so they give you some sample CSV files, and then a sample JSON file, and then a sample README file, right? So then I was hoping that there'd be some sort of sample image file in there. There wasn't, so then I just uploaded the sample image file to the sample data file, and then created it there. And then it's an image of a man on a laptop, if you didn't know. It's a image I got from Dolly using ChatGPT. And then it says the image features a man who is prominently featured in the center, working on a laptop. He's wearing glasses and an orange shirt, and he appears to be in a state of shock or anger. His facial expression is tense, and he's yelling or shouting, which is evident from the positioning of his mouth and his eyes. The man's eyes are closed, and his mouth is open, revealing his teeth. His hair is black and appears to be in a ponytail. The man is holding a laptop in his hand, which is open and resting on a table. The laptop has a silver casing and a silver keyboard. There's also a white cord visible in the laptop, which is likely connected to the keyboard. The man is sitting in front of the laptop, which is on, and his arms are crossed, indicating that he is deeply engaged in his work. And it goes on for a few more lines here, right? So kind of just overall showcasing the performance that you can get from this. And then just if you want to execute this and run this on the back end, you just saw this is how easy it is, right? We literally set it up, and then it executes in 2 minutes. And then I just had to update, of course, and then give it an actual image, right? And then so just remember to do that. And then you have it up and running in 2 minutes. You're good to go. Running this model, and then in this instance, I'm running this all for free, right? So I can run this for free in Colab here all day long. But then when you're talking local inference, this is it's a 1.3 billion parameter total model at the end of the day when you're combining the parameters of it all. So overall, it's fractions of a penny to run in every single instance possible. that you could imagine. And then, so because every single time that we're running that query, right, that's sucking on the GPU on the back end, which is kind of where I'm getting that equation. Like running your GPU, no matter what size your GPU is, and your computer is going to cost something, right? And then so, but the thing is that like other thing is that this could be running on your laptop as well, right? So this, I mean, like this is running on my laptop. I could run this locally on my laptop as well, as opposed to Google Colab, which is something that I couldn't do with like even like a Mistral model, right? Like and there's some computers where you could run it locally, but even like it's a stretch to run a 7B model locally. Like people say like, oh yeah, you can run 7B models locally. Like sure you can. You can do it. You're quantizing it. You're doing a whole bunch of stuff to it, right? Like so then it's and you're doing a whole and you're maxing your computer. You're not running anything else on that computer, right? But so 1.3 billion parameters, a lot more reasonable. I can run it on any device. I can run it on a cell phone. It's running good, shrinking down, and then cost per token. So it's that the reason why we're talking about this Llava Nano is the shrinkage and also the performance and the cost per token. And that's the big thing to me is this cost per tokens. So if you need applications that utilize picture to text, image to text, this is going to be your new best friend. If you like this type of content, please like and subscribe. Thank you very much.